Speaking of jail, nothing. I've got nothing. Today we're going to talk about the three. I'm wearing a hat. We're going to talk about the three transformations that you learned. One of which being a translation, second of which is being a reflection, third of which is a rotation. Let's remind ourselves how to reflect over an axis that's not an X or a Y axis. On Friday, you learned how to rotate around a point. No, it wasn't Friday. It was Thursday. You learned to rotate around a point, and it was gross and it was awful. But part of it was drawing yourself like a coordinate plane on top of a coordinate plane. Well, what I'm going to do here is I'm going to draw a mirror. Okay, that's not one of the regular axes. So if your line is in the form y equals a number, it's horizontal. If it was in the form x equals a number, it's vertical. So y equals -1 looks like that mirror right there. Let me get that one. Change color. So that's my reflection. That's my mirror. So since Q is already touching the mirror, Q stays there. J is 1, 2 units away from my mirror, so it's going to be 1, 2 units above my mirror J prime. H is 1, 2, 3, 4 units under my mirror, 1, 2, 3, 4 units above my mirror. It's a shame none of you are named Amira because I'd be having a whole lot of fun with you right now. It's happened on several occasions where I've taught screens to people named Amira, and boy, is it crazy. 4 years ago, I had a student named Paige. Imagine what it was like getting out a book. Oh, she was traumatized. Thank you, Camilla. Because you laughed at me, I'm not angry at you anymore. My objective is I will be able to perform more than one transformation on the coordinate plane. It's called compositions when you do more than one transformation. Here, we'll just pretend that word is math. And I love the serious picture with a picture looking off in the distance type picture. The one with a cat is the best. Compositions of transformations. A composition of a transformation, again, is when you do more than one thing. So if I'm like, here, take this shape and reflect it and then rotate it, that's called a composition. Okay, that's called a composition. A glide reflection, as you can see as one of you mentioned, from the feet below, is when you reflect, or it's a translation followed by a reflection of a line. It's, again, this is just words that we don't need to know. So if you're looking at this, you're reflecting and then moving. You're reflecting and then moving. It's like when you walk in real life, you go left foot, right foot, left foot, right foot. It's just verbiage that really isn't super important. I'm not going to be like, hey guys, how's it going? What's a glide reflection? All it means is you have a composite, or rather, a composite, also known as a composition, where you reflect and translate. And in this case, you just take turns doing the same. Don't overthink it. A reflection over parallel lines just ends up being a translation. The best way to think of this is when you are in like a room where you're looking at a mirror and there's a mirror behind you. So you're just looking at an infinite amount of yourself, if that makes sense. And half of that infinite amount of your reflections is your mirror image, but the other half is what you appear. So basically, if I were to reflect once and then reflect again, I have the same hand moved over. So what we're seeing here is if I have two mirrors and those mirrors are 5 feet apart, then what you're going to see in your reflection is going to appear to be the same exact thing 10 feet apart. That's what it's going to appear to be. And we will do a problem like that and explain what we did. Again, if your mirrors are a certain amount of units away from each other, then if you reflect it twice, your overall result is going to be double the distance between your two mirrors. Okay. So, yeah, crazy. Last thing, if I have a mirror here and a mirror here, and I have a shape on one side of the double mirror, the end result is going to be what seems to be a rotation. Okay. And if your angle of rotation is 90 degrees, then your end result is going to be boom 90, boom, double 90, which is 180. That's what this is saying here. So this is saying if you were to take a shape and rotate it over a line, not rotate it, I'm sorry, reflect it over a line and reflect it over a different line, and those lines aren't parallel, your final result is going to be twice the angle created by the two mirrors. So I know I threw a lot at you there, and you probably feel like throwing up. Speaking of throwing, but don't. Remember, you guys have been emailed these notes, so if you're able to access them pretty easily, don't go crazy. Don't, speaking of throwing up, don't blow chunks writing all this stuff down and trying to draw all the pictures, because it's there for you. Now, if you do want to draw a picture, that's a picture that you can draw to the best of your ability. So you're going to be drawing that picture. Now, I know what you're thinking. Mr. Perich, you're the one who's drawing by making us do all this work. And that's really funny. It's really funny. But seriously, if you have scrap paper, draw that picture. For those of you who don't know, drawing is Norristown slang for being ridiculous. When Norristown kid be like, "Hey, Mr. Perich, you drawing," that means I'm just being ridiculous. Or they might use the phrase, "I'm out of pocket." I'm out of pocket. Another Norristown phrase. So this is what I'm dealing with here. You ready? In my incredible ability to draw a picture, yes. In my incredible ability to draw pictures, you're going to see some magic happen. I have this triangle living right here on the left side. I'm going to reflect it over M first. So that dot is going to be there. D is going to be somewhere up here. And that guy is going to be like right there. So no cap. I didn't draw that too bad. No cap. I'm not capping, guys. But if I'm going to reflect it over P, then what's going to happen is I get that. So in the end, Lincoln Park, in the end, when I'm done, it appears that this guy, all this guy did was just move over. How far does it look like it moved over? It looks like it moved over, I'd say 4 centimeters. Now, how do I know it's 4 centimeters? Because when things move, let me close down a few of my tabs because it's kind of laggy. Where am I getting 4 centimeters from? Well, in the chat, you tell me where I'm getting 4 centimeters from. The 2 centimeters, what to the 2? Double it. Good. So Santiago said, Santi said, I'm getting the 4 centimeters because in this rule back here, it says when I have parallel lines, which is what I had, and I reflect it, it's going to look like all it did in the end was move over, as you can see from P and P double prime, by the way. That's P double prime. And if these two lines are 2 centimeters apart, then the end result is going to be 2 times 2 centimeters apart. And that's what gave me the 4 centimeters. So, in class, if we were all to have paper and this would be printed out for you, which it would be, because if I send you the notes, then obviously I would print out the notes to you. It would be much easier to do. But right now, you guys are just like trying to recreate your own pictures and try to visualize what's going on. That's why I'm very content making these videos, so that if you're like, oh, I'm just not sure, you can watch the videos over and over and over again. And of course, I'm also looking forward to blowing up on YouTube someday and just walking around with stacks of cash this fat and getting some night. Oh, dude, I kid you not. If I already told you what I would do if I get 400 subscribers. If I get 4 million subscribers, I will definitely ice out my teeth. I promise you. I promise you, if I get 4 million subscribers, I will ice out my teeth. Please make that happen. It's not. I'm not asking for much. Just 4 million, guys. Just there's 12 of you, so if each of you can like just talk to 250,000 of your friends, like it'll be done. Just it's only each of you talk to 250,000 friends, and then I'll have my 4 million. Easy. Thank you. Those of you casting doubt on this, shame on you. Before I move on to the next one, with the one that we just did had parallel lines. These guys have intersecting lines. So if I were to reflect that guy over there and then reflect it over L, it's going to look like a rotation when all is said and done. The angle of rotation, or the angle that's created by the intersecting line, say it's 50, my rotation is going to be 2 times 50, 100. That's going to be my angle of rotation. So me describing a single transformation would be me saying, this was a translation that was 4 centimeters. Translation, 4 centimeters. Translation, oh my gosh. Translation, 4 centimeters. Here, what I'm going to do is I'm going to take that original shape and reflect it over M, and then take that shape and reflect it over P. The best thing to do is kind of tilt your head a little bit so it looks like M is dead on. I don't want to rotate my computer though, but this is going to happen there. That's going to happen about there, and that is going to happen about there. Seems a bit big. I don't like that third dot that I drew. That, you know what, this dot is the dot that I don't like. I like that, and I don't even like that dot. Oh, oh. All right, so I'd say that's a good dot. I'd say boom, boom. That's a pretty good dot. And I'd say boom, boom. That's a good dot. All right. And the D would be there. Reflecting it over here would be me going there and putting a dot like maybe right there, me going here and putting a dot like maybe way the heck over there, and me putting a dot here and maybe putting a dot over there. Not far enough. There we go. Again, this would be so much easier with paper. And as you can see, my picture does not at all do this service. So if I had a sheet of paper to do this on, you know, I'm such an idiot because the next 3 problems I put on paper, I could have put this on paper. So I would literally hold my, I would twist my paper around and be like, and then twist it out again, and then, but instead I did it here, and it doesn't look that great. However, describe a single transformation that maps. Well, when you have intersecting lines, what you do is you rotate. And if someone wants to put in the chat how many degrees, I'd be very pleased. Oh, rhymed. And I'll say counterclockwise. You don't need to, but counterclockwise, how many degrees here? Not 180. Take the number that you see here and do something similar that we did with the last problem to it. Where did I get that? Good. Oh, so close, Santiago. I'll pretend that that was a typo. There we go. Double the 105. Just like we doubled the 2 centimeters last time, we're going to double the 105. It was a typo. I believe you. Speaking of typo, I don't know why that happened, but I'm now going to move to my document camera. I'm not going. Oh, wait. Wrong button. No, please. Oh, things are happening, guys. Things are happening in DC. Oh, boy. And by DC, I mean the DC universe, comics, nothing else. All right, so please, for the love of God, zoom up on pin my screen so you can see things a little bit better. Okay, pin my screen so that things appear to be better. And I'm just straightening this out as best as I can. No, that looks awful. Everything is awful. Everything's not good when you're part of a team. So what I'm doing is I'm doing a composition of two things where my job in this case is to take that shape and rotate it 180 first and then reflect it over the x-axis. So rotate it 180 first. Right now, unless you have this printed out, you're just watching. It's very difficult to try to recreate your own coordinate plane and have it look like something that I stole from the internet, which I did, and recreate it. It's very, very, very difficult. So what I want you to do is I just want you to watch and understand the process so that when we do have to deal with problems on a test or whatever, and that's one of the main reasons why I want to push your test a little bit, is I'm not sure how I'm going to have you do this test. It's very hard to do virtually. So this might be one of those things where if they don't change when we come back in person, I actually might be going to the building on Tuesday, not tomorrow, next Tuesday. And if that's the case, I just might print out the tests there and actually deliver them to your houses. We'll see. I don't know. We'll play by ear. Who knows what's going to happen? I knows. Name that movie. SpongeBob. It's actually a TV show. It's Doodle Bob. Rotate 180 degrees. I didn't say counterclockwise because it doesn't really matter if all you do is spin it upside down. That's what I'm going to do. So the first thing that I'm going to do is, you're in Georgia? I hope there's a lot of stuff. Wow. Okay. Well, tell the new senators I said hello. What am I doing? Okay. So I'm taking my angle, or my center of rotation was that dot. So I'm going to rewrite these. And do I have Post-it notes laying around? No, I don't. You know what I do have? This chewing gum. You guys can't see what I'm doing, but I'm pulling out chewing gum, and I'm going to chew this chewing gum. Oh. I'm going to write down these points as they appear. It appears to me that V prime has me going left 1, 2, and not moving up or down. And it appears to me that going J prime has me go left 1, up 1. It appears to me that Y prime has me going left 1, 2, 3, 4, 5, up 1, 2, 3. And it appears to me that going to R prime is going to be going left 1, 2, 3, 4, up 1, 2, 3. Fix your shape. Graph those points that I have upside down there. If you have to, please turn your Chromebooks upside down. V prime is negative 2, 0. J prime was negative 1, 1. Y prime was negative 5, 3. And R prime was negative 4, 3. Negative 4, 3? Oh, yeah. What you doing in Georgia? She said she can't breathe, so should I call? There's nobody I could call.
A visiting family.
Oh, okay. Well, thanks for coming to class. Now I'm going to reflect it over the x-axis. If I were to reflect V prime and V prime's touching the mirror, then V prime and V double prime are the same thing. Okay? J prime is 1 unit up, which means J double prime is going to be 1 unit down. R prime is 1, 2, 3 units up, so R double prime is 1, 2, 3 units down. And Y prime is 1, 2, 3 units up, so Y double prime is 1, 2, 3 units down. Well, man, it looks like a logo if I were to have another lime shape there. Right, bros? A logo. I'm going to adjust it. Does that look good? I'm just being humorous. I'm just being humorous. Reflect in the y-axis. Here's my y-axis. I'm going to make my mirror image. Y is 1, 2, 3, 4, 5 units away. So Y prime is 1, 2, 3, 4, 5 units away. G is 1, 2, 3, 4 units away. G prime is 1, 2, 3, 4 units away. OG. Ooh, OG, original gangster, right, guys? F is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. F prime. Did I accidentally double prime G? I shouldn't have. Oh, cool. The same exact shape that we had there. Now what? Well, step number 2 says I translate according to the translation vector of -1, -5. What does that mean? Left 1, down 5. And I'm going to take turns doing that. Starting out with Y, left 1, down 1, 2, 3, 4, 5, Y double prime. G is left 1, down 1, 2, 3, 4, 5, G double prime. And F is left 1, down 1, 2, 3, 4, 5, F double prime. And in the end, I have the exact same shape. This is a glide translation. I just want to glide. Put my arms around you, baby. Put my arms around you, baby. That is the music group Sugar Ray. I saw them live at Westchester University once. I touched Mark McGrath. If you don't know who Mark McGrath is, search him. You're probably going to be like, oh, my mom loves that guy. I guarantee you she does. On the other side, Paul. I believe there's a casino and a prison there too. Oh, this one's going to be troublesome. This one's going to be a dandy. This one's going to be a doozy. This one's going to be a doozy. First things first, let's translate this entire shape for -1, which means right 4, down 1. I don't like orange. I love the color, but I don't like how it shows up on this. I got 4 dots. 1, 2, 3, 4, down 1, K prime. M 1, 2, 3, 4, down 1, M prime. Right, 1, 2, 3, 4, down 1, and that is J prime. And right, 1, 2, 3, 4, down 1, and that's C prime, baby. I'm going to now rotate it 270 degrees clockwise about the point 10. Where's the point 10? Here it is. That's 10. That's my point of rotation. I'm going to go 270 degrees clockwise. So that's 1 turn like a clock, 2 turns like a clock, 3 turns like a clock. I'm going to also draw my new coordinate plane. And as I list these points out, I'm listing them out in vector notation because once I fix my picture, it's not necessarily where I put the points, it's where I put the points according to my axis of rotation or my center of rotation. So if I start out with C, C doesn't move. So C double prime is going to be 0, 0. Since C lives on that point of rotation, it doesn't move. If I want to get to J, J double prime means I don't move left or right, and I move up 3. If this is throwing you off, watch the rotations video that I made you guys. K double prime is going to have me going right 1, 2, 3, 4, 5, up 1, 2, 3, 4. So K double prime has me going right 5, up 4. And M, was that M? It is M. M has me going right 1, 2, 3, down 1. So M double prime has vector notation of right 3, down 1. Now fix it. The way I get to C prime is I go to my point of rotation and I don't move. So there's C double prime right there. The way I get to J double prime is I go to my point of rotation and I don't move, go up 3. So 1, 2, 3, J double prime. The way I get to my K double prime is I start at my point of rotation and I go right 5, which I don't have space for, but I'm going to force it, up 4. So right 1, 2, 3, 4, 5, up 1, 2, 3, 4. So I'm falling off the graph, but that's fine. It's really not that bad. And the way I get to my M prime is I go to my point of rotation. I go right 3, down 1, right 1, 2, 3, down 1, and that's M double prime. Wah, 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 wah. So it's the same exact shape. And if you kind of look at it, you're like, oh yeah, I see it. It is the same exact shape. It's the same exact shape, just rotated and reflected. Was it reflected? Translated. Rotated and translated. Trollated. It's a mix between rotate and translate. Trollated. Trollolololol. Remember that video, guys? Is that the guy where he's like, yeah, 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 yeah. I forget the song. So going back to our notes, you know, if I want to look at that picture that should appear on the screen any second now, instead of looking at my big dumb face, I have my own face pinned on my own screen. If you look at the notes, I'm asking you about a girl named Tanisha. Tanisha. It's probably Tonisha. And she's knitting a scarf using the tumbling blocks pattern shown on the right. Describe the transformations combined to transform the red figure to the blue figure. Well, you're reflecting and you're reflecting again. So in the end, when you reflect and reflect again, you just end up translating, as we saw from the very first thing that we did, the very first problem that we did. So like, you know, these would be the parallel lines. And so this guy reflects onto that guy, and then that guy reflects onto that guy, which just ends up looking like a translation. KS translation. Well, babies, that's all I've got.